Okay, so we're talking about strings again, and strings obviously will be part of probably every program you write. They're very important. So before we get into them, I want to show you this. So we've used plus equals plenty. Once again, it just means to increment or increase the value by 3. So when you're done, x is 8. People make the mistake of writing this, which actually has a meaning. So if you write this, and you intended to write this, which you almost certainly did, then it counts as logical error. And you can see it just replaces the value with 3. In other words, equals plus it isn't really a thing. It just interprets it as equals plus 3. The spacing doesn't really matter, so it replaces the 5 with the positive 3, which once again isn't what we wanted, almost certainly. All right, now we talked about this before. Strings are stored as an array of chars, like the string object uses an array inside to store the characters. Anyway, the thing to really first and foremost be clear about is the difference between the length of the string, which there are 7 characters here if you count them, and the spots. Once again, the spots are numbered 0 on up to 1 less than the length, always. And so you expect you to know that. Also, be clear about the difference between the string object, which is created by the code on the right, and once again, you can just put a string literal inside the quotes, and Java will make a string object for you. And then S is the variable. It'll store the string object, but it's not the object. It's like the name of the object, if you will. And then like champ is the name of this object. And so it's kind of weird because we're not talking about other kinds of objects like rectangles and circles and objects like that. That the variable is the only real name you can think of. These are well, they're text. But really, once again, the text is an object, and the variable stores a reference to it. And I keep saying reference because, once again, the object is in memory somewhere, and when you talk about object-oriented programming, you have the data, which would be the characters in this case, and then you also have the methods all bundled up together inside of an object. And so, like here's our picture. Here's the object, and once again, it wouldn't just be those 7 characters. It would be all the length method, the substring method, all the other methods every string object has. That's encapsulated inside that object, and then S stores a reference to that. And when I say a reference, it's just a memory location, which is just a number. And just real quick, about concatenation. We've been doing this plenty. And so if you add 2 strings, in this case there's 2 string variables, but it's going to take the contents and concatenate them. And altogether those are 8 characters, by the way. And so when you print it, you see the 8 characters. When you call that object's length method, then you get 8 because there's 8 characters. And just for the record, that last character would be about spot 7, and then for the C would be at spot 0. Now, the new thing that we're going to be talking about is string methods, and the string methods are all return methods. And when you have a return method, as it says here, the first thing is the access level, which is normally public. There's public and private, and a couple more that we're not going to get into. And then, so you have the access level, which will be public, mostly, the return type, and then the method name, and then the parameters. And so, here's a method called twice. It returns an int. So it produces that as an answer. So like here, if someone called this method and gave an input of 5, for instance, it would return an answer twice as big, or 10. And this is, once again, this is the return type, telling what kind of answer it must produce. So, and we've been using return methods. The next methods that scanners have produce, like in this case, an int, and then we've been storing the result. And of course, the types need to match. If it's next double, then you store it into a double variable, obviously. Now, if you look at this, here's that same return method I was showing you. Let's say it's in a class called return1. Well, then if you want to call that method, then you first have to make an object, in this case a return1 object, and then you can call that method. And once again, this, here watch, like if we're running the program, this is the main method, so it does the first command, then it does the next command, and there's two actual commands on this same line. There's the print command and the twice command. It actually has to do the twice command first. Even though this comes first, it has to do this first, And so jump in here, X will be storing the 25 that was inputted, and then it calculates 25 times 2 is 50, and then it returns where? Well, back here to where that method was called. And so, and of course it brings the 50 with it, that was the answer, and passes the 50 on to the print statement, which then would print the 50. And then it move on to the next line of code, and once again it's going to call the twice method, pass in 17, calculate the 34, and then return that answer back here, which then gets passed on the print method and gets printed there. And that's how programs run, actually. Now, about the string methods. There's a number of them. There's a lot more than this, but these are the ones we're going to learn. There's a few more, actually, that we'll learn beyond this. There's two different substring methods, which I'll explain in a minute, but it returns a part of the string, hence the name. Notice, by the way, the second S is not capitalized. That would be because substring is a word in its own right. So it's not camel-cased, like index of, char at, last index of. Those are camel-cased because there's more than one word as part of the name. Length is obvious. Char at gives you the character. We tend to use substring more because char at gives you a char, and we're not going to study those, but there's ints, there's doubles, there's also chars, and so it can be helpful, but it can also be tricky. But then index of we'll definitely talk about, and last index of is same idea. Let's just get into it. So once again, if there's 7 characters, then length would return 7, and then the last spot would be one less than that. One thing I want to stress again is, like, if you have a string variable that's storing null, there is no string object, and so that's different from like this bottom one where it's storing an empty string. So like here, and by the way, they would all compile because the compiler doesn't know that there's no object here. It says which would run. Well, this is the line of code that would not run. It would give you an error. It would give you null pointer exception, technically, and because there is no object. Whereas here, it would give you 5 as the answer, and then after this, X would be 0. Now, char at, like I said, it just gives you the character of that spot, and so this is spot 0, so you get C, spot 1, spot 2, so that's M at spot 2, and the last character is always spot length minus 1. Then substring, like I said, there's 2 versions. If you do say substring 3, then you get from that spot to the end, and so that would be PSCI. If you do 2 numbers, the first number is where you start, the second number is where you end, but the catch is you go up to but not including that second number. So 2 to 5 would actually get you 2, 3, and 4. So it's inclusive of the 2 but exclusive of the 5. That's the way we talk about it. And so for spots 2, 3, and 4 get you MPS. That's the output. Nice little check is to subtract these numbers. 5 minus 2 is 3. That should be the length of your answer when you're doing this version substring. And then this last one from 4 to 6 gives you, once again, from 4 to 6, but not including spot 6. So really just 4 and 5, which is that 2-character substring. And then you can write stuff like this. So here you're getting from spot 1 to the up to but not including the last spot. And so you notice what you don't, we omitted spot 0, so you don't have the C. We omitted the last spot, so we got the middle basically. Notice what's happening here is it's actually getting smaller and smaller. The same code, like I said, captures the middle. It basically gets rid of the first character and the last character, and so it gets smaller and smaller. The reason is substring, it produces a smaller, it doesn't change the string, it produces that new string and returns that new string. So if you just put it in a print statement, then the original string is untouched. But what happens here is we're storing the new string, and so like compsci, S was storing compsci. After this, it's storing omps, and then after this, it loses the O and the C, so it's storing MPS. And then if you do it again, you lose the M and the S, since you're just storing P. Once again, the key is that the S equals makes it store that new string. If it had been like this, notice nothing would have changed. because it's just capturing everything, the middle every time, but always the middle of the original string. Because, like I said, the substring method doesn't modify the original. Now, index of, it basically does a search. It searches through the string, starting at the beginning, and returns the first place where it finds that. And so, like in our example, we're doing searching for MP. Well, that substring is found, and it's found at spots 2 and 3, but index of returns one number, and so it can't return 2 and 3, so it returns the first number 2. So that'd be the first answer. And then if you're looking for a C, the C is at spot 0, so that'd be 0. If you're looking for X, X is not there. And so think about this. Index of returns an int, and it can't return, like if it doesn't find it, it can't return false, because that's not an int, that's a Boolean. And so they programmed it to produce a negative, because that's never a valid spot. And they chose -1 because that's just a simple answer. So that's what happens, is it returns -1. Now last index of, it's the same idea. It returns where it finds it, but it starts looking from the back, from the end. And so in this case, if you look for C, it will return the one at spot 5, or it will return 5. Now, omp, there's only one omp in the string, so if you did index of or last index of, you'd get 1 either way. Now, I was kind of alluding to this earlier. There's this word immutable, and string objects are immutable, which means you can't change them. And so, I'm going to keep saying the string class does not have modifier methods. The substring method doesn't modify the original string. It produces a new string. And so, you can change a string variable. So like S can store one string, and then you can replace that string with a new string. That's different from saying that original string object could be modified, because it can't. So you can see the old string object got replaced with a new one. And I keep saying that, but now, like I said, immutable objects, you can't change what they store. The nice thing about, and this is the main reason to do or have immutable objects, is that we've talked about how you can have two variables point to the same object, and the advantage to that is, as it says here, you save space. You don't have to have create that same object over and over again. And also it makes things, and if you're going to do that though, then you want to make it safe to do that, because look, the idea here is, imagine like two of us know the address of the house, okay? Well, then one person could go modify the house, paint it, and without the other person knowing. And so that's kind of the idea. You can have one variable modify an object, and in separate programs even, in theory. And then the other program doesn't realize it got changed, and it leads to all really hard errors to find. So if you want to work with variables like this, the best thing to do is make it so you can't change the object. In other words, you make the object immutable. They could have made it so every time you get a new object, you get a new object, and then you'd avoid that error, but then you take up more space. All right, here's another example. So if I, it's all lowercase, and if I call the two uppercase, it does what you expect. And if I print the result, then I see that new string, but once again, the two uppercase is not a modifier method. It doesn't change that object. It's still storing all lowercase. If I did this, s equals s dot two uppercase, now I'm storing that new string that two uppercase produced, and the original lowercase gets disposed of. So that's what you have to keep in mind when dealing with strings. Is that you can't change the original string. You have to store the new string if you actually want to do that. A few more methods, and we'll be done. The equals method, and that's what you should use to compare strings, not the equal sign. And then there's a compare to method, and of course I've already mentioned uppercase to uppercase. So first of all, look at this. I have 1 and 2, these variables storing two different strings. They're different objects that store the same text, comp sci. if I did 1 equals 2, it's going to compare what the variables store, and the variables are storing different memory locations, different references. And so you're going to get not equal, which is not good. It's not the way to compare objects. You should use the equals method, and it's going to return true if they store the same text. Then the compare to method is used to compare two strings, see which one's bigger, which one's smaller. It does so by returning a number, either positive or negative or 0. And so now, technically, it subtracts the ASCII codes. And so, listen, capital letters have smaller ASCII codes than lowercase letters, which is weird. But the main point, and so you have to be careful about that if they're capital versus lowercase. But like capital A is, comes before capital B on the ASCII chart, and so forth. So basically A comes before B, so if you subtract their codes, if you do A minus B, you'd get a negative, which would tell you that A comes first, which of course we know it does. If you did B minus A, you get a positive, which tells you B is bigger. And so in other words, it would come after it. So that's basically what compare tos does. So here's some examples. W is lowercase abc. And notice if you compare it to capital, you get a positive, because like I said, lowercase has a bigger ASCII code. Now, if you compare lowercase abc to lowercase abb, what it actually compares is the C here with the B here, because the first two characters are the same. It's the third characters that are different. And if you do C minus B, it would technically subtract their codes, but they're 1 apart, so the answer is 1. And the fact that it's positive means ABC is bigger, which it is. If you, I know they're not really words, but if you put them in the dictionary, ABC would come after ABB. And if you compare ABC to itself, of course you get 0. And if you compare ABC to ABD, it's going to subtract C minus D and get negative 1, which tells you ABC is smaller, or it comes first. And then, as I said, capitals are smaller than lowercase, and so when I compared lowercase to capital, I get a positive because lowercase are bigger. But if I put the capitals first, then I get a negative. Now that's the main rule. There is a special rule that happens, like in this example. So here you got ABC, you have AB. They're identical as far as they go, but this one doesn't have a third character. So the rule in that case is you just subtract lengths, and this string is one longer, so it's bigger by 1. And if I compare ABC to A, it's bigger by 2. If I compare ABC to this longer string, well, now this length of 3 minus this length of 6 gives a negative 3, and that's all it's doing is subtracting lengths. All right, that is all. And like I said, memorize all these string methods.